Suppose I've written a function which is meant to do something that you wanted it to do. You might well ask me, well, why should I trust your definition? And really, there are three ways I can try and persuade you. The first I can do is apply some tests. I can try the function at a few possible input values and see how it behaves on those. So that covers some of the possible inputs, but clearly doesn't cover everything. So that's what we have on the left. On the right, we have a notion that we might do a mathematical proof that the function behaves in a particular way. And that, in principle, that can prove, it can become a mathematical certainty that the function behaves as it should. But it's hard work doing mathematical proof. And so, it's not something we do in a routine way, even though it is relatively straightforward for functional programs. What I'm going to talk about in this segment is a situation which is halfway between testing and proof, and that's called property-based testing, where we're able to test a particular property of a function on a whole lot of randomly generated data. It doesn't guarantee that the function has the property we want, but it covers a much wider range of inputs than simply testing does. And it's about the same degree of difficulty as writing a test, whereas proof, which of course gives us certainty, is a lot more work. So property-based testing using the QuickCheck program is something which has become very popular. QuickCheck was invented for Haskell, and now you can find clones of QuickCheck for many other languages, functional and object-oriented and so on. Let me try and explain what is going on in a bit more detail by looking at an example. So we might think of rotating a picture in two ways. We could flip it horizontally and then vertically, or we could flip it vertically and then horizontally. And I think we'd probably agree, and the picture is fairly convincing, that whichever way around you do it, you get the same result. And we can write a test like that. So I've written one that I apply the flip H, then flip V, and flip V, then flip H to the horse picture, and I check, do I get the same result? And the answer is yes, you do. But we could instead write a property that says, a property of an arbitrary picture, pick, that the two different implementations behave in the same way. So we could write a test like that, and then we could test it for 100 randomly generated pictures. Hundreds are default, we could do 1,000, or we could do fewer, by typing QuickCheck of that property prop rotate. And what we get in this case is we get, okay, it passed 100 tests. So we've checked it not with just one test now, but we checked it with 100 randomly generated pictures. So that increases our confidence that it does what it should be doing. What does the result of QuickCheck look like in practice? We saw earlier that it could say, okay, passed 100 tests, but suppose I give a property in the bottom half, I give a property that flip H of a picture is the same as flip V of a picture. And when I've done the QuickCheck on that property, I get failed, falsified after 4 tests and 2 shrinks. And here's a counterexample. If we take the list with list A and empty list, if you apply flip H and flip V to that, you get 2 different results. Unsurprising. But in that situation, when we are told that the property check has failed, we know that the property is false because we're given evidence, we're given an example that shows how it can be false. So we know it's not true. What's the situation if we get an OK? What we get in that situation is we know the property holds in 100 cases, but it still might not be true. So you have to be careful with property-based testing. For example, if you randomly check whether a number is greater than 1,000,000, you will pass an awful lot of tests in QuickCheck before it generates a number, randomly generates a number over 1,000,000. So, and people spend a lot of time talking about trying to find ways of improving the way that QuickCheck generates its 100 random tests. But just beware that just because QuickCheck says it's okay doesn't mean it necessarily is. But you have got assurance that at least it's passed 100 random tests, which is more potentially than your 1 or 2 handwritten tests. So it's clearly of value. On the other hand, the gold standard, if you like, for correctness would be to prove the mathematical property. And here they actually hidden under this flip v and flip h are reverse and map. And what we're trying to prove here is if we map f along a list of x's and then reverse the result, we get the same as reversing x's and then mapping f. And you can see that that really should be true if you understand what map and reverse are doing. But what we can do, in fact, is once we have definitions of reverse and map, we can use induction, which is a bit like, it sits alongside recursion, to prove properties like this. But we can't do that at the moment because we've not even seen how those functions are defined. So it's possible to do that. It's obviously the best if we can do it, but it takes substantially more effort, and therefore it's not done in a routine way. Right, well, that's the end of this discussion of a very brief discussion of testing and property-based testing. We'll see some more examples of property-based testing further down the line, but it's useful for you to see it at least introduced and get the general idea of what's going on there.